Good evening students. Today we are going to discuss about the electrostatic potential. So what is in the electrostatic potential? The electrostatic potential means the amount of work done to bring a unit positive charge from infinity to the point in the region of the external electric field. Okay students, what is in the electrostatic potential? Electrostatic potential means the amount of work done to bring a unit positive charge from infinity to the point in the region of the external electric field is called electrostatic potential. To discuss about this electrostatic potential, why we need to discuss about the electrostatic potential means already in 11th standard you studied about the gravitational potential. So what is the meaning for gravitational potential? Gravitational potential means the amount of work done to bring a unit mass from infinity to the point against the gravitational force is called a gravitational potential. Here the gravitational potential is one of the conservative forces. Already you studied in the 11th standard. Same as here we are discussing about the gravitational electrostatic force. In this electrostatic force, to discuss about the electric field due to the electric dipole, or we are discussing about this electric field due to the electric charges, we are taking a positive charge that is moves from one point to another point. Like this, here there is a positive charge, it is moves from the one point to another point means we turn the work. That the amount of work done, that amount of work is stored as energy. That energy is called electrostatic potential energy. Okay students, are you understand? I hope you understand well about the electrostatic potential energy. Electrostatic potential energy means it is nothing but the amount of work done to bring the unit positive charge from one point to another point is called electrostatic potential energy. Electrostatic potential energy means the amount of work done to bring a unit positive charge from one point to another point is called electrostatic potential energy. So generally the electrostatic potential means the amount of work done to bring a unit positive charge from infinity to the point in the region of the external electric field is called electrostatic potential. To discuss about this, here we consider one of the charge that is a plus q. Plus q is placed here, and then we take the another one point that is a point P. In this point P, we are going to calculate the electric field of the charge q. To calculate this electric field at a point P due to the charge q, we are taking one of the positive charges. That positive charge, it is also bringing from infinity to the point. Here we take, this is a point R. From the point R, we are taking the test charge, that is a positive charge. It is also bringing from the point R to P. So here, this is one of the electric field. Against the electric field, we are moving the charge from the point R to P means here between these charges there is experience a repulsive force. So against the repulsive force, we need to move the positive charge means we need to do external work. That amount of work done is stored as energy, that is called electrostatic potential energy. Okay students, So from this, what is in the electrostatic potential energy? The amount of work done to bring a unit positive charge from one point to another point is called electrostatic potential energy. Electrostatic potential energy. Okay. So here in a derivation, we can give that the amount of work done means that the amount of work done is stored as energy, that is called electrostatic potential energy. So to calculate that amount of work done, that amount of work done means we turn the work. That work done is notable letter F external. We have turned the work. This work, it is opposite to the Coulomb force. So here we turn the work. Thus this work, it is done against the Coulomb force. Against the Coulomb force. So we can write F external. External force is equal to opposite to the Coulomb force. Opposite to the Coulomb force. So by using this concept, we can write the amount of work done W is equal to integral of external force in the dr vector. Here we can write the integral start from Q end to P. So what is in the work? Work is equal to force into distance. Force into distance. By using that concept, we can write the W is equal to integral of Q to P F external. F external means that is the external force. Displacement means here it is moves from the R to P. So it is given the integral of Q to P dr. Okay students? Right. So you can write this amount of work done is stored as energy. That energy is called electrostatic potential energy. That electrostatic potential energy is noted by letter del U. Here this del U, it can be written as the difference between the potential energy at a point P and the potential energy at a point R. So from this we can write the work done is equal to potential energy. That electrostatic potential energy is equal to the difference between the potential at a point P and at a point R. So we can write W is equal to del U. It is equal to UP minus UR. So from this we can write del U is equal to integral of R to P external force in the dr vector. Okay, it is also equal to, what is the meaning for external force? This external force is equal to opposite to the Coulomb force. So we can write that Coulomb force F Coulomb is equal to minus Q dash E. So we can write integral of R to P. What is F external? F external is equal to opposite to the QE. Coulomb force is equal to Q into E. So we can write F external. F external is equal to opposite to the F Coulomb. So we can write minus Q dash E. So minus Q dash E. Okay. So why we are taking this Q dash means here we can take this charge. The test charge is not a better Q dash because here the point charge is taken as Q. So only here it is taken as Q dash. Okay. So here this is integral of R to P minus Q dash E into dr vector. Okay students. So from this it can be written as del U is equal to, we can take this Q dash E on outside minus Q dash E integral of R to P dr. Okay. Right. So from this next step it can be written as del U is equal to minus Q dash E in the integral of R to P dr. Okay. So this is one of the electrostatic potential. So you can calculate the electrostatic potential energy per unit charge. The electrostatic potential energy per unit charge del U divided by Q dash. The electrostatic potential energy per unit charge, this is one of the total electrostatic potential energy. Here this is the electrostatic potential energy per unit charge del U divided by Q dash is equal to minus Q dash E in the integral of r to be tr. This is vector quantity tr divided by q dash. So q dash cancelled means what is the final answer? That is integral of r to p minus e into dr. This is the electrostatic potential energy per unit charge. This electrostatic potential energy per unit charge, it is also give the difference between the electrostatic potential. Del U means that is one of the UP minus UR. So we can write this, the electrostatic potential energy per unit charge. It can be written as here the potential difference between the 2 point. So by using this concept here, this equation it can be written as Vp minus Vr. Vp minus Vr means V means electrostatic potential. Okay, electric potential. P means at a point P. Electric potential at a point P minus electric potential at a point R. So it is given the difference between the electric potential between the 2 points. It is equal to integral of r to p minus e into dr. So this is a electrostatic potential energy. So from this concept we are going to calculate electrostatic potential. What is in the electrostatic potential? The electrostatic potential means the amount of work done to bring a unit positive charge from infinity to the point. From infinity to the point. So we can write the electric potential. The electric potential is equal to Vp is equal to, here we consider the point R. Here this positive charge it is bringing from the infinity distance. So we can take infinity to P minus E into dr. So here it can be written as electrostatic potential. So from this, what is the electrostatic potential? The electrostatic potential is defined as the amount of work done to bring a unit positive charge from infinity to the point against the electric field or in the region of the external electric field. Now by using this equation we are going to discuss about the important points about the electrostatic potential. So by using this equation according to the electrostatic potential, here this equation it is depend upon this electric field and the displacement. Electric field and the displacement. Here it is not depend upon the point charge or test charge. Okay, that is very important. So this electrostatic potential is always depends upon the electric field and displacement. Okay, and then here this electrostatic potential it has a unit, that is volt. Volt is one of the unit for the electrostatic potential. Already you know the unit for the potential difference. Okay, that is volt. That only electrostatic potential. Okay students.